So it will be A, C, B. Same thing here. For this one, Q will be A, D, B, right?
Yes, sir.
Okay, so W will be same. Now what will be U? U we already calculated. See here. Delta, not delta. Let's write here. UB minus UA. This is already calculated. What is it? 30 plus, what is ADB? 10 joules. See, it's given in question. So the values are given. Right now we are just solving with pen and pencil or whatever. But in exam, you should have that much practice that while seeing, okay, 60 minus 30, okay, fine. 30 and 30 plus 10, 40. 40 will be the answer. So 10, which is 40 joules. Easy? Yes, few of you said answer as B. Yes, correct answer B. Let's check. It is obvious it should be B. Yeah, it is B. 40 joules. Clear, everyone?
Yes, sir.
Do anyone need more explanation? Or next question?
Next question, sir.
Let's do some good question. Okay, let's try this one. Temperature difference, right? Maintain too raw. Let's try this one. It was same last year, no, last to last year, shift 1, January 9. Get option to be shown, wait. Till then you can read question, I'll just paste option with diagram. Okay, who can explain this question? A little explanation is also okay. Who can do that? Who can do the honors? Give small explanation on. Shall I call anyone randomly? Okay, let's ask Dhairya. Dhairya, give small explanation. What you understood from the question? Not in chat box. No? Okay, Anjali. Yes, Anjali, go on. Speak.
So T1 will be 0. No, like the delta T will be 120 degrees Celsius. I still don't understand like the bent like the same the bent rod PQ of same cross section as AB. That part. So I need to look at the picture for some more time.
Sure. Okay, Vishwanath. You should know this. Come on, Vishwa. Yes, Vishwanath. Give small explanation. No? Okay, then. Anyone else? No one? Shruti, Neha, Divya, Adisha. Okay, then let me tell you small thing. Chalo, theek hai. See what they're saying. The length of each section, we have like L, this is here, and L by 4 on the sides, right? So this will be L, then remaining will be L by 2, L by 2. Okay, this way we can do something else. The temperature difference of 120 degrees Celsius is maintained between two ends of uniform rod AB. So this is our uniform rod A and B. Length is 3L by 2. So 3L by 2 minus L means 1.5 L minus L, which is 0.5 L. 0.5 means L by 2. Therefore, this is L by 2 and this one is L by 2. Okay. This thing we got it, fine. So this thing we got it, L by 2, L by 2. Next thing we need to use the temperature. What are the options we have? Celsius, 45, 35, 75, 60. Think with answer only. We have to just move around this one. Current, temperature. Okay. So you can think here. P and Q. So what is P and Q? This one. So this one we need to find a temperature. So for that we need T temperature, this one minus TQ. Let's go from bottom, okay. If we cannot go from top, just let's go from answer, okay. We need this TP minus TQ as sum of this one, any of ABCD. So this temperature difference, okay, let's assume this one as some resistance. Suppose, let's assume this way with a length, because R is directly proportional to length, right? So if we assume that length as R, whatever value of length we have, we can assume that as R, then we might be able to solve. Let's see that. Okay. This length. This is what? How much it is? L. L means R here. Right. And this length was L by 4, means R by 4. So this is also R by 4. This is R. And this is R by 2. Length is directly proportional to resistance. That's what we are taking as resistance. Now, if you solve this length as a resistance, so this is in series, so R plus R by 4 plus R by 4, what we get? 4, 5, 6. And this one, and with parallel with R. And R by 2 plus R by 2. So this will be parallel with R, and this combination will be series with R by 2 plus R by 2 plus this value, this total value. Calculate this total value and tell me what is the R value. So 3R by 2 plus parallel, right? So 2 by 3R plus 1 by 5, 3R by 5 plus R by 2 plus R by 2 into 5 and 2 means 6 and 5, 7, 8. 8R by 5. Okay, so total R is 8R by 5. I'll erase this and directly write 8R by 5. You know to solve, right? You know to solve resistance, na? Everyone? 12th standard people we know, but 11th standard, do you remember? Release of 12th standard, right? Okay, Adisha. Do you remember solving of resistance? And Divya, are you for 11th or 12th?
12th, sir.
Okay, then you might have completed, right? Yes. And Neha, are you from 11th or 12th? Okay. So 11th. And Shruti, you remember this?
Yes, sir.
Right. So don't forget those things. Okay, just write here directly. We got 8R by 5. I'll just write this. So this net resistance is 8R by 5. Oh. Now, we need to relate with this one and this resistance, temperature and resistance somehow. So we have one relation, that is current. Current in thermal. Same thing now. Thermal current, what is here? A and B. So I equals to thermal current. I equals thermal current T AB, temperature at AB, which is divided by total resistance. Okay. So what is TAB? Temperature difference across AB, steady state. Okay. It is 0 minus 120. 120 divided by 8R by 5, which is 120 into 5 by 8R. Now let's go with TP minus TQ. TP minus TQ, which is equals to I into that net resistance 3R. No, sorry. 8R. No, wait. Here, this is TP minus TQ. Current will be same, fine, but we need to find for P and Q. So P and Q was, how much it was? What is the value for this square? So I don't have to solve again. Tell me. What's the value for this square? If you have written. Tell me fast. What was R equivalent for that square itself? P and Q. Not this whole AB. Follow. And then I have to solve again. Tell me. I erased that. Yes, Adesha. What was this PQ value? Total resistance of this PQ. Nobody wrote or what? Shruti, did you write? Am I audible? No.
Sir, I got 8R by 5 only. PQ resistance.
There is net resistance, no? 8R by Q, that's net resistance total A and B. What was PQ? Okay, I'll solve that again. R by 2, 3R by 2. And is 2 by 3R plus 1 by R. So 3R by 5. Okay, and then substitute I value. 120 into 5 by 8R, which is equals to, sorry, into 3R by 5. R will get cancelled, 5 and 5 will get cancelled. -45°. A is the option. Yes, any doubt in this question? Shall I explain again?
No, sir.
Fine. Because we just choose what length is directly proportional to resistance, as we have studied. Length increase, resistance increase. Similar way, we are using same concept here. So that because we don't have any direct values here. Right, we are trying to get this value by this current combination, resistance combination. And we are connecting with thermal current. So I is here thermal current. Okay, let's go for next question then. Have we done Carnot engine? Didn't start, right? Did any Carnot cycle question? Yeah. We did for 12th April, second shift. Let me see which is that. No, it's 9th Jan. Okay, let's do this one then. It has some hint also, but we won't see hint. Without hint, we'll do. Okay. Options, right? Can someone try explaining this question? Okay, this time who will try? Anjali tried last time. Yes, Divya, you try. It doesn't matter right or wrong, just tell me what you understood from the question. Yes, Divya, try. Hello?
Yes, sir.
Yeah. Explain. Okay, thinking. Okay, fine. straightforward question. Come on. Yes. Okay. See, whenever this question comes, Carnot cycle, always draw source and sink. Heat going or heat outgoing or heat incoming. Okay, in Carnot, just tell me just general form. What will be in Carnot cycle? Work will be input or work will be output? Here's the area. The area is not there. Okay. Vishwanath. In Carnot cycle, heat will, work done will be input or output. Carnot engine. Vishwanath, are you there or busy in watching those some background serials or movies? I guess so busy. Yes, Shruti. In Carnot engine, work is input or output? Shruti?
Output, sir.
Exactly. And heat will be
Heat.
input, right?
Yes, sir.
Okay. And what will be opposite of this one? Refrigerator. In refrigeration, it will be opposite. Okay, fine. Yeah, I asked somebody, yeah, Divya, yeah, back to you. I think so by now you have read the question and you understood. Give some points. Oh, it's easy, come on. Try. Okay, for this question, let me give you a detailed solution. Then remaining question, you don't need to get detailed solution. You can just see an answer. It's actually very easy, but I'll give you detailed solution first, step by step. Remember the steps, what I'm doing here. First, it is T1. What is given here? 600K. Then rejects reservoirs are at temperature T2, and second engine B is receives heat, and first engine and rejects at 400K. Fine. This is your T1. 600K Kelvin. It's giving an engine A. Then here heat supplied. Let's take Q1. It gives work. Then exit what? Heat rejected from system A and heat received by system B. So here we'll attach system B or engine B. This will be Q2. So B will have temperature T2. A is having temperature T1. So B will release Q2. we will release Q2. Then output W we are getting now. This is heat rejected by source. That is Q3. Now let's take this as a sink here. Some sink is here. Which is how much temperature T3, which is 400.
400 K.
And T1, what was T1 here? 600, right? Yeah.
600 K.
That's it. Anything left? First one. Are we missing any point here? T3 we have, T1 we have, T2 we need to find out. Anything left?
No, sir.
No, right? Okay. So Q1 is what? Heat rejected by engine A. You can write this for the first time if you're solving, then write this so that you will remember for next time. Q1 is heat rejected by engine A at temperature T1. Then from there, we are going to Q2. Q2 is heat received by engine B at temperature T2. And then next we have Q3. Heat rejected by engine B to the source T3. Then we need to write about W1 and W2. So W1 will be this one, right? So W1 will be Q1 minus Q2 because it's going this way, Q1 minus Q2. And that W2 will be Q2 minus Q3. So both work done should be same. Let's equate this. Which is Q1 minus Q2, Q2 minus Q3. So if I solve this, Q1 minus Q3 equals to 2Q2. So do we have Q1, Q2? We don't have, right? We have only temperatures. Fine. Then let's convert this as a temperature. So how to convert this one as a temperature? By the ratios, simple. So Q1 by Q2 minus Q3 by Q2. This will be minus or plus? This will be plus, right? Is this you're not telling me? Yeah, this will be plus only, correct? I just saw this side. It's okay if I'm doing any calculation mistake, you can stop me there and tell me. So there is wrong here. Okay, then we know the ratio, right? Same. T1 by T2 plus T3 by T2, which is equals to 2. So here we can find 2. Then why we came here like this? We can directly write here, no? T1 plus T3 by 2, which is T2. 600 and I think so 400 if I'm not wrong. Yeah. 1000 by 2 is 500. 500 is the answer. If the work are equal, right? I got this idea from given terms. Clear? Easy?
Yes, sir.
Any doubts now? Will you be able to solve if I give you some other questions?
Yes, sir.
One yes, then Disha,
Yes, sir.
two yes. Anjali,
Yes, sir.
three yes, okay. Neha and Vishwa,
Yes, sir.
okay. Hello, Anjali. Is she there? Okay, the next Carnot engine, let me search. Oh yeah, next question is a Carnot cycle. But this a little bit different. Okay. There are three Carnot engines. Very good. Super. 1, 2, and 3. चलो चलो भैया ये सॉल्व करो विदाउट गूगल अंकल ओनली जयविन भैया ये सॉल्व करके दिखाओ I'll be happy. Yeah, if you don't know Hindi, I'm saying solve this question. I'll be most happy. This is easy actually. Nothing big here. Just three engines they are given. Come on. Try this. Until you try, I would allow you to go. But even I cannot stop also, right? It's online class. चलो बच्चा लोग सॉल्व करके दिखाओ Shoot, I forgot charger. Yes, बच्चा लोग, any progress? Will think, sir, let us solve first. If you are asking, but okay, I'm asking so that you won't sleep while solving. Three Carnot engines optical series between three heat source, temperature T1 and sink the temperature T4. See the figure. There are two other reservoirs at temperature T2 and T3. With T1 more than T2 more than. Engines are efficient, equally efficient. Okay. That means efficiency 1 equals to efficiency 2 equals to efficiency 3. Simple. Yeah, question is done. Find out 3 efficiencies and equal it. Finish. 2-step answer. Come on. Not 2 steps. No. If we put this, there are 1 equation, 3 unknowns. So we need to get in 1 in other form. Yes. So N1, N2, N3. So first we'll equate N1, N2, then second time we'll equate N2, N3. You get 2 values. Then we can solve. So yeah, try this way. N1, N2, N3. There will be 3 equals, right? So first 2, N1 and N2 equate it and get in 1 temperature, maybe whatever it is. 2 and N3. From that get 1 value, which is, see, when you solve for second one, N1, N2, N3, get in terms that is already there in first one. Try to get that. Then you'll be easily able to solve it. Because see the option. See, every time I'm saying this thing, that see the option. We have T2 and T3. So always go with option T2, T3. You should have as option in your mind. You should have option in your mind. You should not use more than 3-4 steps. Don't take so much time. See, first one efficiency are equal. That's what they are saying. N1, N2, N3. So N1, for N1 diagram, okay. T2 minus T1, right? So T2 by T1, 1 minus T2 by T1, 1 minus N2 will be T. This one T3 by T2. Same way T4 by T3. So this both term will get cancelled, all these 3. So T2 by T1 equals to T3 by T2, which is equals to T4 by T3. So get 2 equations. So T2 square equals to T1, T3. T3 square equals to T2, T4. Write these values in this one. I want is T square. So T2 power 4, which is equals to T1 square, and T2, T4. Three. It's not 3 steps, right? It's making more. Okay. T2 cube, which is T1 square, T4. Do we have option this one? Yes. T square and T4. T square and T4, yes, 1 power. B should be the option. Let's try for let's confirm with third point. Sorry. This one we got, then next we need T3. Substitute this T value, T2, T1 square, T4 1 by 3, then T3 square equals to T1 square T4 1 by 3 we need in terms of 1 by 3 T1 and T4. Did we miss anything? Yeah, we can use that one, not T2 value. Yes. Yeah, that's what we are using. Then let's substitute this 2 value here. Value here. T2, T4, T2, 4, T2 square, T4 square. So instead of T2, we can substitute T1 T3 the whole square. No. T1 T3 T4 square. So T3 and T will get cancelled. It will be T3 cube T1 T4 square, which is T1 T4 square to the power 1 by 3. Yes, finally we got it. Yeah. See, we can do anyhow, anyway, but option should be in our mind. Are we getting same? Yes, that's it. See, it took time, but yeah, we solved it and we got 4 points. Yeah, any doubt in this one? Yes, people?
No, sir.
No? Everyone? Disha? Anjali? Vidya? Vishwanath? Clear? Okay. Still I'm waiting for Anjali and Divya.
Sir, can you explain once again the T3 part?
Sure.
Thank
See
you,
what?
sir.
Yeah. See this one, like what we did here, we just equate by the equation given. They all have equal efficiency. If so, we just started there itself. N1, N2, N3. So we know efficiency like 1 minus T2 minus T2 by T1, T3 minus second one T3 by T2, and fourth one T4 by T3. So from that we got this relation. So first two we are equating, we are getting this value. Second one we are equating, we are getting this value. Then from this one we are substituting T3 as T4 and T2. So here we got T2 that as This is a final form. T2 equals to T1 square T4 to the power 1 by 3. Now, that is in option B. Now we need to get T3. So see the option for that. T1 T power T4 as square and T3. So remember this option is mine. Then we need to solve. Keep option in mind. So T3 we have this. Now I want to substitute T square here from this part. Let's name it as A. This is B. And C is the answer. So from A, I need T square. So it is not T, it is T2 here. We need T2 square. So I'm squared everything. So T power 4, T3 4, and T2 power 2, T4 power 2. So then I substituted T2 as T1, T3, and T3, T3 cancel. So we are left with T3 cube. And here T1 and T4 power 2. That's it. Then T3 is T1, T4 square, power 1 by 3. That's what we need as an option B. Is there any other option? Similar option? No, right? Only D, but D is not same as this one. So this should be the option B. See, even you can stop it here also because there is no similar option for as C. Or option D, B. We don't have any similar thing, right? Do we have any similar T squared, T4? No, right? Yes. So you can stop here. I'm going to solve this one. But if you have, then you need to solve anyhow. Because this is not descriptive test. This is objective. So you got half option correct. That's it. But you should be like 100% sure. Yes, this is my correct answer. I was sure. Yes, this is correct. Then I was not sure, so I will solve here. I'm not sure for B part, so I want to confirm. So I solved it. Clear? Divya?
Yes, sir.
Okay. Then I'll give you one or two questions. Then we can end. Let's say this term you are able to, okay, this is different now. I don't have much engine question. Okay, I'll give you some other question then. Not engine, then some other. Try it. Unknown metal of mass. Just try it. It's about calorimetry. Try as homework. Question 1. Actually, calorimetry questions are like so calculative. So have patience while solving. Take these two questions as a homework. Take a screenshot or make a note of it, whatever you want. Easy is to take a screenshot. But then after taking screenshot, don't use Google Lens. Right? Yeah. Second question.
Yes, sir.
Let's stop sharing.